Greetings and welcome to the introduction to astronomy. In this lecture, we are going to talk about the different types of spectra that we see in astronomy and how they can be used to better understand astronomical objects. So how do we make a spectrum first? Well, we can create a spectrum. First of all, we see white light. That's what we're used to seeing. And white light is composed of all the colors of the rainbow. So it is a mixture of all the different colors of red through violet. Now, when we put that light through a prism, so here is the white light coming in. When that strikes the prism, each time it crosses the edge of the prism, it gets bent. And different wavelengths get bent by different amounts. The violet light gets bent more. So it ends up down here. So when the light comes out, then we have red on one side, violet on the other, and we will have a spectrum. So the prism is one way of putting light into its component colors. There are others that are used as well. Now, why is this useful? What is useful about it? Well, first of all, we talked about black body radiation in a previous lecture. There we learn about the temperature and the brightness. Those are the two things we talked about. Spectral lines help us learn more things. We can learn the composition. What are stars made up of? Well, we can use the spectral lines to determine what a spectrum is made. We can use the spectrum to determine the compositions and the velocity of stars. How are stars moving? So it increases our knowledge of stars by being able to study the spectrum of those stars. So let's look at the different types of spectra that can be formed. And first, we're going to look at a continuous spectrum. This is formed by a solid, a liquid, or a dense gas. And that may seem like just about everything, but many of the astronomical objects are not necessarily this. In a continuous spectrum, there are no breaks. In this case, we see visible light red through violet, although a continuous spectrum could include all electromagnetic radiation, gamma rays through radio waves. These are emitted by a black body source. So things like an incandescent light bulb with a filament that is heated up in it, or that would be an example of a black body. And it would give you a continuous spectrum. The burners on an electric stove would be something else similar that would do this. If we ignore the atmosphere of a star is a decent black body and would give a continuous spectrum. However, the atmosphere will change that. Now, there's another type of spectrum we call the emission spectrum. And we see that here. An emission spectrum or bright line spectrum has only very specific lines that are visible. So instead of seeing the entire spectrum, we see only these very specific wavelengths. This is formed by a diffuse gas. And we see this excited gases, things like nebulae that we will look at, will give out an emission spectrum. And this is where we start to see learning what these lines are tells us what objects are made up of. This happens to be the spectrum of hydrogen gas. So if we see this spectrum, then we know that hydrogen gas is present. Now, the third type of spectrum is an absorption spectrum. So we see this is formed when a continuous source is viewed through a cooler gas. So it's kind of a combination type thing. And we see specific wavelengths removed. So we have an underlying continuous spectrum with very specific lines that are removed that tell us what, again, these tell us what the objects are made up of. So things like this line happens to be sodium. These happen to be calcium. The others are other elements that are present in the sun and in other stars. So if we look at stars and planets with the atmosphere, we would get a spectrum like this. So this is what we would see for the sun. And again, that tells us at least some part of telling us what the sun is made up of. At least we can know what material is present there. Now let's kind of put this all together in a little bit of a schematic to see here. And what we have is we can look again. We're doing the same types of spectra. This is the continuous, the emission, and the absorption. And we can see how each of them are formed. So we talked a little bit about what they looked like. And here we see them, the continuous, the emission, and the absorption spectrum. But here is our continuous source. So if we look directly at that, we would get a continuous spectrum. We would get the entire colors of the rainbow in the visible light. If we look at that light through a cloud of gas, then very specific wavelengths would be removed. And those wavelengths correspond to material in that gas. So again, we're learning about the composition and what this is made up of. When we look at the bright line spectrum, we're looking at just the cloud of gas. So here it's a cool cloud of gas because we're looking at it relative to a much hotter continuous source. When we look at it this way, we're looking at a hot gas because it's hot relative to the background of space. Now what you note is that the lines will be the same. So we will see the same sets of lines in a continuous and in a continuous spectrum if we're looking at the same cloud of gas. So you might see this red line and this red line and so on. So in an ideal case, you would see exactly the same lines in each case, because again, the lines tell us the composition. So this is how we've been able to learn what things are made up of. We look at those spectral lines. Now there's a little bit more detail to it than just looking at the spectral lines, but it does give us a start, because if we see an element's spectral lines present, say in a star, then we know that element is present. However, the converse is not true. Just because we don't see lines of a specific atom there does not mean that atom is not present. And we will look at that a little more detail in the next lecture, because it has to do with the amount of energy needed to produce each line. Some elements are very tough to excite and cause to give off their lines, so they take more energy. So a very cool object would not be able to show those, even if there was a lot of that element that happened to be present. So let's go ahead and finish up with our summary. And what we have is, we looked at spectra, and again, we used that they can be used to determine many different properties. We looked at what the continuous spectra can tell us a little bit last time, how we can learn the temperature and brightness of an object. And now we looked at, we can learn things like velocities and compositions of stars by looking at the detailed spectra. We looked at the three types. We had the continuous spectrum with no lines, the emission, which was just bright lines, and the absorption spectrum, which was dark lines. And we talked a little bit about Kirchoff's radiation laws, which will tell us under which circumstances each of these spectra will occur. So that concludes this lecture on types of spectra. We'll be back again next time for another topic in astronomy. So until then, have a great day, everyone, and I will see you in class.